Hello folks, and welcome to this lesson on spontaneity and Gibbs energy. By the end of this lesson, you should be able to predict the spontaneity of reactions and solve problems related to Gibbs energy. While we haven't used the term spontaneity in the past, you have looked at topics that are related to this. Mostly in that redox unit where we talked about reactions where you can put it together and yet nothing's actually going to happen. Whereas in other cases, you can put a bunch of things together and they will happen because of E0 values or because something is more reactive or less reactive than something else. So spontaneity has to do with, if you take this thing, will it react on its own or not? Now, in the definition that I am using up here, there is an idea of directionality. That aspect of it is going to make a little bit more sense once we get to the equilibrium stuff. So don't worry too much about the direction aspect of this definition. Just know that when we're talking about something spontaneous, it's will this reaction happen as written if you leave it alone. Now, while we've been talking about enthalpy and entropy, I've sort of been mentioning this whole idea of spontaneity in those aspects. So exothermic reactions tend to be spontaneous, and you've probably seen this a lot as you are experiencing different things in your life as well. The things that release energy are more likely to happen than things that need to absorb energy. And in the same vein, an increase of disorder or things that increase in entropy tend to be spontaneous as well. It'll be easy to figure out if something is going to be spontaneous or not if it's both exothermic and increases entropy, or if it is endothermic and decreases enthalpy. Then you know if it's clearly spontaneous or not spontaneous. But it can get a little bit more complicated if it's not as straightforward, but you can take these values and put them together, and what you get when you put them together is referred to as Gibbs energy. Gibbs energy is a quantity, and you are able to calculate it, and the way that you calculate it is you take this equation. You're going to take your enthalpy and subtract it by the entropy of the reaction and multiply it by the temperature that you're working at. Now, these values, your delta H is and your delta S, the reference values that you see are typically going to be taken in standard conditions rather. But remember that enthalpy is very dependent on, or entropy is very dependent on temperature, and so that's why temperature is put into this calculation as well. Now, like enthalpy, Gibbs energy doesn't have absolute values. So it's always going to be a comparison between your reactants and products. Don't forget to watch your units when you're doing this calculation. Your Gibbs energy is going to have a unit of kilojoules per mole, which is matched by the units for enthalpy, which are also kilojoules per mole. However, your entropy is going to be joules per mole per Kelvin, so make sure that when you're doing this calculation, after you find out what that value is going to be, change it into kilojoules and then move on with the rest of your question. So what can you figure out with this delta G, with that Gibbs energy? Well, you can figure out if a reaction is spontaneous or not, and negative values means that this reaction in these conditions are going to be spontaneous. Now, what happens if you get a delta G value that's 0? Well, in that particular case, it means that it is in equilibrium, and we'll talk about this more in the future, but in equilibrium means that your forward reaction and your backwards reaction are happening at the same rate. So there is no overall change, though, that you can see overall. All right, so let's take a look at the different situations that you can get when it comes to finding out your Gibbs free energy for a particular reaction. So you're going to have, of course, the really obvious ones, If you have a negative delta H and a positive delta S, it's always going to be spontaneous since delta G is always going to be negative. And if it's the opposite of those, it's never going to be spontaneous. It's always going to be positive. Now, if you have a case where your delta H and delta S are both negative or both positive, then it's going to actually depend on this temperature whether your reaction is spontaneous or not. So let's take this situation when you have a negative value here and a negative value here. Now the negative value for your delta S and the negative that is part of the equation is going to mean that this part is going to give you a positive value. So they're sort of working against each other. You're not always going to get a negative or positive value for your delta G. Now, if we're looking at when is a reaction going to be spontaneous, that's typically where we're going to be looking at it, what we need to find is when is delta G going to be negative. Now, this value isn't really going to change no matter what you do, but this portion of the equation can change and its magnitude can change depending on the temperature itself. Now, if we want to find out when your delta G is going to be negative, you need to minimize the effect of this portion of that equation. The smaller this part of it is, the less it's going to actually make this less negative. So if your temperature is going to be small, then that means this entire portion is going to be smaller, which means that positive side of this equation, you're basically going to be lifting this up less if this number is small. Now, if we're going to look at this in terms of the other situation where you have both positive values, remember that when you want to look for spontaneity, you're going to look for delta G being negative. In this situation, this portion of the equation is already giving you a negative number. What's sort of crashing the vibe is your enthalpy value, which is positive, so it's lessening the negative effect of this. And so if you want to ensure that this entire side of the equation ends up being negative, you want high temperatures, because a big temperature number is going to make this value a lot more bigger, and that's the negative, that's the bit that's going to give you that negative. And so at higher temperatures, you're going to have spontaneity. And so this is a type of question that you can get with this sort of thinking in this sort of situation. So you have a certain reaction at 25 degrees Celsius. You have the information for your enthalpy and your entropy. When is the reaction spontaneous? So here you can see that you have a negative value for your enthalpy, which would tend towards spontaneity. However, your entropy is also negative, which means that it would be opposing to the spontaneity. So we are going to be using this particular equation to help us out with this. And let's take a look at when your free energy is 0, because this is going to be that tipping point for whether your reaction is going to be spontaneous or not. The temperature at which you have a 0 Gibbs energy is going to be that tipping point for whether it's spontaneous or not. So if you set up your equation, and don't forget you have to change that entropy into kilojoules, you're going to get this temperature. So once again, this is going to be that tipping point of your entire situation with spontaneity. Now, if you know that this component of this equation is going to be positive, and you know this is the temperature at which it's going to end up, this whole thing ends up being 0, well, if you go any higher than this particular temperature, then this positive value is going to grow, which means that it is going to be above 0. Your Gibbs energy will end up being above 0. So that means if you go higher than this temperature, you are going to get a positive G0 value, or a positive delta G value, and therefore it is going to be non-spontaneous if you go higher. So to answer the question, the reaction is going to be spontaneous below 1900 Kelvin. Now, if you know how to solve inequalities, then go ahead and use that method instead, and then you won't have to do that last bit of mental thinking to figure out which way you have to go, above or below that temperature, but make sure you actually know how to solve them. Otherwise, I will not take it very lightly if you don't use them properly in an evaluation. Now, hopefully you figured out that there probably are going to be free energy values or Gibbs energy values that you can find. And yes, there are standard free energy of formation values that exist. It's your delta G F naught. It's the same sort of idea. Making 1 mole of the substance from the elements in their standard states, etc. and so forth. And of course, you can use these delta G naught F values to be able to find the overall delta G of a reaction as well. And so you can also get this type of a question where you're asked to find the Gibbs energy of an overall reaction given the Gibbs energy of formation. And this is going to look very similar to many things you've done before. And so here you go. Do make sure you come and see me if you have any questions about this particular type of question. That's the end of this lesson. I'll see you next time.